In this video, I'm going to tell you how to derive the section formula in coordinate geometry. You are not only going to learn how to prove the section formula, you are also going to see some solved examples or problems based on the section formula. I will also tell you the common mistakes that people do when using the section formula so that you never have to make those mistakes again. Hey guys, this is Vikas Sharma welcoming you on behalf of Exponent to Success to yet another of our videos. And if you haven't subscribed to the channel as yet, do subscribe to it right now and do not forget to click on the bell notification too. So let us straight away go into a Cartesian plane. Let's draw a Cartesian plane for ourselves. Say this is the y-axis and this is the x-axis. And I'll mark them so that this is the x-axis that I have and this is the y-axis, and same this is y dash and this is x dash. So this is a Cartesian plane that I have, and suppose I have 2 points in here. One is a point here and one is a point here. And if we draw a line segment joining these 2 points, in the last video you learned how to find the distance between these 2 points by using the distance formula of coordinate geometry. And if by any chance you happen to miss that video on the distance formula, you should click on the top right corner of the screen. There's a link that will take you straight to the video. Okay, let's start by naming these points. Let us call this point A and let us call this point B. In this video, we are going to talk about the section formula. Section formula means dividing a line segment in a certain ratio. So for example, if we want to divide this line segment AB in the ratio of 1:4. So we say divide AB in the ratio 1:3. That means I need to mark a point somewhere on this line which will divide this line segment AB in a specific ratio, which is the ratio 1:3. So let's say I mark a point here such that this gives me 1 unit and this gives me 3 units. So thus I have divided the line segment AB in the ratio 1:3. Now you could also say that instead of this, if I mark the point here, then this will be 3 units and this will be 1 unit. So this also is in the ratio 1:3. But that will turn out to be wrong because that is the number one common mistake that people make all the time, and you should not make that mistake. So when they say divide AB in the ratio 1:3, that means starting from A, you should have one portion which goes up to a particular point P, and then from P you go 3 units which goes to B. So the order is very important, the order of the line segment as well as the order of ratio. If they had said divide BA in the ratio 1:3, then this arrangement would have been fine. But this has divided AB in the ratio 3:1 and not in the ratio 1:3. And no, they are not the same thing. So you should be careful about that. Okay, so let's get rid of these points and let us put a proper point here which will divide AB in the ratio 1:3. And let's name that point as P. And before I actually get into solving it, I would like to tell you a quick backstory about myself. When I was a student, I used to find the section formula very complicated. And I don't know why I had that fear inside me. But then I did not have the advantage of a good teacher, or I didn't have access to YouTube videos in my student days. But you have all those resources today. And today I'm going to teach you the logic behind the section formula. And talking about logic, I would like to tell you that if you always follow the logic in mathematics, you will never go wrong. Logic is the only thing that needs to be applied in mathematics, and that's what I'm telling you here. You should always understand the why before the how. Before understanding how to solve a question, you should know why we are doing that to solve the question. So always make it a habit for yourself that why am I doing this and why do I have to do this. So for the time being, let's not talk about 1:3. Let's talk about any other ratio, which is say K:L. So if I have to divide AB in the ratio K:12, that means AP should be equal to K units and PB should be equal to L units. And before we proceed with this question, let's find the coordinates of these points too. And you know, to find the coordinates of any point on a Cartesian plane, all you have to do is look at the perpendiculars. So draw a perpendicular to the x-axis. Let's say it meets at the point x1, and then drop a perpendicular to the y-axis, and you see that it meets at the point y1. So the coordinates of this point A would then be x1 comma y1. And same goes for B. If we look at B, we drop a perpendicular at the x-axis and we find that it meets the x-axis at the point x2. We drop a perpendicular to the y-axis and we find that it meets the y-axis at the point y2. So the coordinates of B then would be the abscissa first and then the ordinate. So it would be x2 comma y2. Now let's say that this point P, the coordinates of which are not known, let's call them just x comma y. So what we really need to do is to find the coordinates of the point P, or the abscissa and the ordinate of the point P, write it as an ordered pair x comma y. So ultimately we have to find the value of x and y using these coordinates x1 y1 and x2 y2. Now before we go any further, let's drop a perpendicular to the x-axis from the point P also. So let's say this is a perpendicular from the point P on the x-axis, and this is a perpendicular from the point P to the y-axis. So this coordinate we know should be point y, and this coordinate should be point x. Now starting from the point A, if I drop a perpendicular to the line here starting from P, so I get a 90 degrees angle here. And again from the point P, I drop a perpendicular to the line going vertically from the point B. So I get a right angle here also. Now what we see here are two triangles, and to name the triangles, to make it a little easier for myself, let's call these points C and D. Now I'm going to write triangles here. So triangles, I have in triangles APC, which is the smaller triangle that you see here, and triangle PBD, which is the bigger triangle that you see here. Now if we talk about these two triangles, we know that this line AC and PD is parallel to each other, so we can write that AC is parallel to PD. And why are they parallel? Because they are both forming 90-degree angle. They are both perpendicular to the same perpendicular lines that we dropped from P and from B. And because they are parallel line, then AP happens to be a transversal, or AB happens to be a transversal between them, and therefore this angle that we have here should be the same as this angle that we have here, because they happen to be corresponding angles on the same side of the transversal and on the same side of the parallel lines. We can also say that angle C is equal to angle D, which are both equal to 90 degrees. And we can also say that angle PAC is equal to angle BPD. And we can write that as corresponding angles. And we know that if two angles of a triangle are equal, then the third angle obviously has to be equal. So we can write that because the triangles are equiangular, equiangular means when they have all the three angles are same. So because the triangles are equiangular, that is why triangle APC is similar to triangle PBD. So if they are similar triangles, what can we say about the corresponding sides in both these triangles? In both these triangles, the corresponding sides have to be in the same ratio, because they happen to be similar triangles. In fact, I've done a video on similar triangles before also, and if you have happened to miss that video by any chance, then I think you should just click on the link given on the top right corner of the screen, and we'll be taken to the video straight away to understand what are the properties of similar triangles. Which means if we look at the corresponding sides here, AC should be equal to PD, because they are corresponding sides, they are the base in both the triangles. And if we talk about the hypotenuse in both the triangles, that should be equal to AP over PB. Now let us find the length of these sides. What is AC here? And because we can say that this line is parallel to the x-axis, therefore to find the distance between these 2 points will be just to subtract the x coordinates. So AC will be equal to x minus x1, starting from x here and going to x1. So that should be equal to x minus x1 over PD. How much is PD? So if I look at PD, then we should take the x coordinates of D, subtract from that the x coordinate of P, and we should get the distance between PD. So the x coordinate of D is x2 minus the x coordinate of P is x. So x minus x1 over x2 minus x should be equal to AP over PB. Now AP we have been given is K and PB is given as L. So that should be in the same ratio. So the ratio should be equal to K is to L. So now people, the major part of the derivation of the section formula or the proof of the section formula is now over. Now all we have to do is to rearrange this equation and we have to find the coordinates of the point P. So to rearrange, let us first start by cross multiplying both these sides. So this becomes L times x minus x1 should be equal to k times x2 minus x. I can simplify this, open the brackets and write it as Lx minus Lx1. That should be equal to kx2 minus kx. Now since I need to find the value of x, let's bring the x's to one side and the other things to the other side. So I add kx to both the sides. So I get kx plus lx minus lx1. That should give me kx2. And because we are running out of space here, let's delete these things, move these things on top. Okay, now I need only the x's on one side, so I don't need this term lx1 on this side. So to cancel this out from the left hand side, all we have to do is to add lx1 to both the sides of the equation. So I get kx plus lx should give me equal to lx1 plus kx2. Then I factor out x from both the terms, so I get x times k plus l should be equal to lx1 plus kx2, and then I divide both sides by k plus l. So dividing the left hand side, I am left with only x, and this will be lx1 plus kx2 over k plus l. Now be very careful about this part that we have done here, the rearrangement, because a lot of people make mistakes and finding the x coordinate and the y coordinate. This isn't tricky if you just understand it. All we did was we just cross multiplied both the sides, we simplified it, we took all the x's to the same side, we factored out x and we divided the other side by k plus l, and we get this. So this is the second most common mistake that people do, and this is why I'm telling you that you need to be thorough with it, what to do, why exactly do we do it. This is just because we want to find the value of x and y here. So because we need to find the value of x and y, that is why we are keeping x on this on one side and taking everything else on the other side. So this, my students, is the x coordinate of the point P. So I'll write it as lx1 plus kx2 over k plus l. That is the x coordinate, and we need to find the y coordinate now, and once we do that, we'll get it as an ordered pair, and those would be the coordinates of the point P. Now I don't need to go into the same derivation again. I can just say that because these both are similar triangles, therefore the ratio BC over BD, which is the perpendiculars of both the triangles PC BD, they should be in the same ratio as k is to l, and we need to find the value of PC and BD. So PC, you see, is the y coordinate here minus the y coordinate here, so it becomes y minus y1 over BD. BD is the y coordinate here minus the y coordinate here, so that should be equal to y2 minus y. That should be equal to the ratio k over l. And then you can just follow these steps, cross multiply, bring all the x's on one side, factor out x, divide by k plus l, and you get the y coordinate as, and the y coordinate that you get will be very similar to the x coordinate. All you have to do is just replace x1 and x2 by y1 and y2. So you get L y1 plus L y2 over k plus l. So that's the y coordinate of the point P. Now what you need to notice and look carefully is this part here, Lx1. Now if you see, x1 is the coordinate of the point A, and A to P is the ratio k, it is not L, but we are multiplying the x coordinate by L and not by k. So the order has got reversed because of the cross multiplication that we did here. And that is what you have to always be careful about. The x1 coordinate will always be multiplied by this ratio here, and this x2 has to be multiplied by the ratio this over here. So Lx1 plus kx2, so Lx1 plus kx2 divided by k plus l. So you add k and l together, and that will give you the x coordinate. Same goes for y. It is Ly1, so Ly1 plus k y2 over the sum of k plus l. And this is what is the number 3 most common mistake that people do. So this is what you have to be careful about. Don't confuse this. This can be written as lx1 plus kx2 upon k plus l, or if you want l and k in the alphabetical order, you can do it as kx2 plus lx1 over k plus l. That is going to give you the same thing, but remember that k, the first ratio, has to be multiplied by the coordinates of the second point, while the second ratio has to be multiplied by the coordinates of the first point. Okay, now let's get rid of all this and let's solve some questions on it. But before we jump into the questions, I would like to ask you how you are finding this video so far. Are you liking it? Do you think that the section formula is easy? Well, I found it to be easy once I understood the logic behind it, and I've tried my best to explain or to impart that logic to you people also. And if you have understood the logic, and if you think that you find this easy, then all you have to do is just head to the comment section below and write in a comment for me, leave a comment there. Is it that easy? Just these 4 words. Is it that easy? Just leave this in the comment section and then we'll head over to the questions. And for the next question, we come straight onto the Cartesian plane and we say that we have a point here and we have a line segment which is connecting it to the point here. So we have a line segment AB and we need to divide this line segment in the ratio 3:10. So remember that we have to divide AB in the ratio 3:10. That means we should be able to find out some point P. We don't know where that point P on AB will lie, but that P should be here somewhere such that AP should be equal to 3 units and PB should be equal to 10 units. And we need to find the coordinates of the point P. So to find the coordinates of point P, the first thing that we need to find out are the coordinates of the points A and B. So if I look at the point B, B is meeting the x-axis at the coordinate 3 and the y-axis at the coordinate 2. So the coordinates of B is 3, 2, and the coordinates of A, it is meeting the x-axis at the point 14 and the y-axis at the point 7. So the coordinates of A are 14, 7. So all we have to do is just to find the coordinates of the point P. We know the section formula. Let's put in the coordinates of A and B there and let's find out our answer. So remember the coordinates A is 14, 7 and B is 3, 2. So we head over here. We write that A is equal to 14, 7 and B is equal to 3, 2. And we need to divide AB in the ratio 3/10. Let us take this as x1 and y1 and let us take these points as x2 and y2, and we need to find the coordinates of point P which are x, y. So the coordinates of point P, which as an ordered pair would be x, y, should be equal to, the x coordinate should be L times x1. So L, this is in the ratio k/L. So L here is 10. So it's 10 times the x1. X1 is 14. So 10 times 14 plus kx2. So k here is 3. So 3 times x2 is 3. So plus 3 over k plus L. K plus L is 10 plus 3, which is 13. And the y coordinates will be ly1. So L is 10. So 10 comma y1 is 7 plus ly2. Sorry, I made a mistake there. That should not be ly2. It should be ky2. So I'll write it as ky2. So this becomes k is 3. So 3 times y2. Y2 is 2 over k plus L. So k plus L again is 13. And then I need to just simplify this and find the coordinates of x, y. So this becomes 140 plus 9 over 13, 10 times 7 is 70 plus 6 over 13. So this will give me 149 over 13 and this will give me 76 over 13. And if we simplify that, we get the ordered pair xy as 11.46. So I can write it as 11.5 comma 5.84, or I can just leave it as 5.8. So the coordinates of the point P should be 11.5 comma 5.8. Now let's mark that on the graph also and see whether that looks to be correct or not. So we need to mark the point 11.5 comma 5.8. Now 11.5 is the x coordinate, so let's look at the x-axis. Where is 11.5? 11.5 should be somewhere here, and we see where is 5.8. 5.8 should be somewhere here, so that is where it is meeting. This is the point P that we have, and we see that this looks more or less correct, that this looks to be 3 units and this looks to be 10 units. So yes, we have been able to divide this line segment AB in the ratio 3 is to 10, and all by just using the section formula. This is what you need to do. So the coordinates of both the points will be given to you. You need to find the coordinates of another point P, which will divide the line segment in a certain ratio that will again be given to you. So that's all we have to do. But sometimes there is a situation that you might get a question where you are not given the coordinates of the one of the points. So you might not be given the coordinates of A, or you might not be given the coordinates of B. So you can be given the coordinates of B, and you can be said that there is a point P which divides AB in the ratio this is to this. So you have to find the coordinates of point A. Let's do a question something like that also, and then let's see what we get. So the second question that we have is given to us here, that we have to find the coordinates of point B if the point P having coordinates of 4.6, 2.2 divides AB in the ratio 1 is to 4, given that the coordinates of point A are 3, 1. Now first of all, let us write down what information do we have. So what we have is that point A is the coordinates are 3, 1. Point B, we don't know what the coordinates are, so we'll just leave it as blank, blank. Then there's a point P which is dividing the line segment AB. The coordinates of that are 4.6, 2.2, and the ratio is 1 is to 4. Now also let us write down what do we have here. So we have that this is x1, this is y1, x2 we do not know, y2 we do not know, we need to find that. This is x y, so this is the one that is the point P in the middle here, so that coordinates we already know, and this is the ratio k is to L. Now with this information, if we put all this information back into the section formula, we can find out the coordinates of point B, which means x2 and y2 we need to find out. Okay, let us start with the formula first. So we know that x is equal to Lx1 plus kx2 over k plus L, and y is equal to Ly1 plus ky2 over k plus L. Okay, so all we have to do is substitute these values. So we know that x is equal to 4.6. So we know that 4.6 is equal to Lx1. So L we know is 4. 4 times x1 is 3. So 4 times 3 plus k we know is 1. So 1 times x2. x2 we have no idea what that is. So let's just write that as x2 only, over k plus L. K is 1, L is 4. So that becomes 5. And here y we know is 2.2. So 2.2 is equal to L, which is 4, times y1. y1 is 1 plus k, which is 1, times y2, which we don't have any idea. So let's leave it like y2 only, over k plus L. K plus L is again 1 plus 4, which is 5. Multiplying both sides by 5, we get 4.6 times 5, which is 23. So 23 should be equal to 4 times 3 is 12, plus 1 times x2 is x2, and the 5 and 5 get cancelled there. And here we get 5 times 2.2 gives me 11. So 11 is equal to 4 times 1 is 4, plus 1 times y2 is y2, and again 5 and 5 get cancelled. So that means we subtract 12 from both sides. So x2 is equal to 23 minus 12, and here we subtract 4 from both sides. So we get y2 is equal to 11 minus 4. Therefore x2 is equal to 11 and y2 is equal to 7. So the coordinates of point B should be 11, 7. Now to verify the answer, we'll just draw a rough figure and see whether our answer works or not. We'll draw a rough diagram to see where the points are and whether our answer is really correct or not. So just to test, what I'm going to do is I'm going to mark these points very quickly. So if we have the point 3, 1, so 3 comma 1 should be the point here, and we have 11 comma 7, so 3 4 5 6 7 8 9 10 11, and 7 should be 1 2 3 4 5 6 7, so it should be somewhere here. So that means this is our line segment here from this point to this point, and let's see where the point P is. So P is 4.6, so 4.6 would be so if this is 4.6 would be somewhere here. Okay, and 2.2, 2.2, yes, it should be here. So this is where the point P is, and this is A and this is B. So do you think this is one portion and this is 4 portions? Well, maybe the figure is not accurate, but it does look approximately 4 times the length of AP. And then we have another extension to the section formula too, which is a special case of the section formula, which I'm going to talk about in the next video. And if you do not want to miss that video, you must click on my picture on the screen, because that will subscribe you to the channel. And while you're subscribing, do not also forget to click on the notification bell. And I would really appreciate if you show your love by liking the video below and by sharing the link with your friends. And also do not forget to click these videos appearing on the screen right now, because I can assure you that these are going to change your life. So take care. God bless.